Okay, so we'll start with the chapter today, chapter 3, pair of linear equation two variables. Right? Now, this word, especially this word, linear equation in two variables. This you have heard in class 9, isn't it? Did you heard of this name in class 9? Linear equation two variables. Okay. So that means you have some idea of linear equation two variable. So what is linear equation two variable means? Can you give anybody can give an example? Anybody can give an example? Linear equation two variables? No? 2x plus 3y is equal to 4. Yes, this is a example of linear equation two variables, because first of all there are two variables you can see. One is x. Okay, one is x, other variable is y, and also it is a linear equation because the power degrees of these variable are 1. Here it's also 1, it's here it's also 1, so it's called linear equation in two variable. Right? Now if you have linear equation in two variables, so what we will do here in class 10 is that we have something called pair. We'll have pair of linear equation. In class 9 you had single linear equation, right? But in class 10 we have pair. Now why we have pair and what is the use, we'll discuss in the entire chapter. But let us come back to this linear equation two variable, the basic structure whatever we have. Let us come to this. So I'll put today's date here. Today's date is 26th, okay, April. Now the general form of linear equation in two variable is this. This is the general form. Now here this a, b and c are any real number, right? And x and y are the variable. In class 9, if you had a linear equation two variable, like a child has given an example here, 2x plus 3y is equal to 4, he said, but I'll write 5 here. If I give you this linear equation, then can you give me a solution of this linear equation? Solution means a value of x, okay, and a value of y, so that when I replace this x and y with these values, the entire equation left hand side right hand side becomes equal. That's called solution. Can you suggest a solution? हाँ बोलो solution. Can you give suggestions? Uh, okay, that's fine. But any solution? Can you give me a concrete solution? Answer. There's an infinite. Give one solution. There is an infinite solution. Give one solution to me. Anybody can? One per each means. Okay, very good. X is equal to 1 and y is equal to 1. That's the solution of this equation, because if I replace x with 1 and y is 1, it becomes 2 plus 3, which is 5. So that's fine, absolutely fine. So there are many solutions possible. Like if I take x as 2.5 and y as 0, still it is a solution. X minus 1, y 2, not 2, not 2, it's not 2, because no, because it's not 2. Now, if you take something else, it will not be. It will be 7/3. Yes, 7/3. Because 7/3, if you replace 3 and 3 will cancel, 7 will left here, -2, and that will be 5. So this is also solution. So like that, if you have one linear equation, single linear equation in two variable, then you have how many solutions? We have infinite many solutions. Okay. We have infinite solutions. Now, if we have two instead of one linear equation, where this actually our 10th class chapter begins, then what will happen? Now, in that case, what will happen here, that we'll take the first equation and we'll name it this first equation as a1x, b1y, and c1 is equal to 0. This is one. And second equation will be a2x, b2y is c2 is equal to 0. So these are two equations, because we have two linear equations, so we have to do it like that. Right. Write properly because one was not visible. Yeah. So now we have two linear equation, and this chapter, if you started with, if you remember, it started with pair of linear equations. So we'll get always two linear equations. Now what happens in two linear equations? If you get, now there can be three possible types of solution. What three types of solution, that I'll tell you. But before that, what I'll do, I'll just give an explanation that for each of the linear equation, we'll be able to draw graph. We have learned how to draw the graph of a linear equation in class 9. Let us say the first equation I take, the graph of this first equation comes out to be something of this kind of line. Okay. And the second equation, the line comes out to be like this. It's possible on the same graph sheet. If I take the first equation, draw the line, a line can come like this. Second equation, line can come like this. And if you notice that the two line crosses at one point. Now this point, this point, this one is a solution for both the line. Why solution? Let's say this is having a value of m comma n. This is a coordinate. Okay, let's say this coordinate is m comma n. So if I replace the first equation, all the x and the y with m and n, the left hand side will become 0. Similarly, second equation, if I replace x with m and y with n, it also becomes 0, because this point exists in both the line. It is also present here, it's also present. So this is the solution for both the line. So if the solution, so we say it is a common solution for these two equations. Is this clear what I said? Okay. Yes, it is a unique solution. That is good. Now there may be one more possible thing, that the two lines may not cross like this. Okay. The second line which we draw, let us say it is something like this. Okay. So both the lines are what? Both the lines are they're parallel, almost parallel, because the line will not cross. So this line will have some individual solutions. Okay, these lines will have it because these are the coordinates. This line will also have some individual solution, but both the line will have infinite solution of their own, but they won't have a common solution because they don't intersect. Okay? So that may be a condition. This is the second one. So first one we said when the line crosses. Second line, if the lines are parallel. And what is the third condition? Third condition means when the line overlaps one on the other. It overlaps one over the other. How it's possible? I'll draw another graph and show it to you. So let's say this is the our axis, x-axis, y-axis. So if you draw one line, and the second line which you draw also falls on this, overlaps. Okay, it overlaps on this. So all the solution of the first line are also the solution of second line, because this is a common point for all. So infinite solution of first one and infinite solution of second, both are common, exactly same. So that means they have infinite solutions. So when you have pair of linear equation, there are three possible outcomes. You may have a unique solution or a one solution. You may have no solution. You may have infinite solution. The same thing concept we are going to learn now. Now what I'll do, I'll not be going according to the NCRT book pages. I'll be choosing my own way of doing it, right? Because first what we'll discuss here is the types of solution what we get. I'll show you some graph if it's possible. I'll show you some graph, right? So if you see the graph, I think so you can see this graph. So this graph if you see, two lines are there, right? And both the lines are both the lines are this is one line, this is the second line, they intersect. So this is intersecting case. Then we have something like this where you can say they are overlapping. Okay. They are overlapping now. You can see there are two equation written. One is written here, one is written here. There are two different equations, but they have common line. So this is a case where overlapping things come, and this is the case where you have parallel lines. Right? We have parallel lines. You can see here the lines are parallel. This is one equation, this is the second equation. The first equation goes line like this, second goes like this. They have individual different solution. Now when we get two linear equation, how will we be knowing that, without drawing the graph, that will this line will be parallel like this, or it will be a intersecting line, or it will be a overlapping line? For that, what we have something called solubility condition, and for that we have a process by which we can decide. So that is given on in your NCRT book. In your NCRT book, it is given as a table number 3.4, and this is, I think, the page number 11. I think so. I believe. Let me check. This is page number 46, not 11. Sorry, 46. This table. So all of you can see the table. Yes. So how we will be deciding that which what type of solution we have? So for that, what we will do, I will shift this table slightly on this side because I have space to write. Now see here, generally what we have linear equation in two variables. General equation like this: a1x plus b1y plus c1 is equal to 0, and the second equation is a2x plus b2y plus c2 is equal to 0. Now this a1, b1, c1, these are all real numbers, and a1 and b1 are coefficient. Here a2, b2 are coefficient. So what we do, we take the ratio of this coefficient. If the ratio of a1 upon a2 and b1 and b2 are not equal like this, then the line geometrically they will intersect, the one which I showed, and algebraically means they have actually one solution. We say is unique solution. So you have to remember this, that for any two equation, if a1 upon a2 is not equal to b1 and b2, they will intersect and they will have exactly one solution. If the things are like this, that a1 upon a2 will be equal to b1 b2 and will be equal to c1 or c2, that means all the three ratio a1 upon a2, don't take the variable x and y, you should leave it on the coefficient a1 upon a2, b1 b2, c1 with the sign. If you take it and you find they are equal, so it is called coincident. Coincident is overlapping lines, and they have an infinite many solution. So this also you have to remember. And third possibility is that if A1 upon A2 becomes equal to C1 is B1 upon B2 but not equal to C1 upon C2, the lines will be parallel and they don't have any common solution, we say no solution. So this part of the table is very important because question do ask on these conditions. So you have to remember it. So now what we will do, we will take some question based on this, how to solve. And as I told you that I'm not going to take the book as it is given in the NCERT. So I will first do exercise 3.2. 3.1 we will be doing later on. And this also not all the questions will do together. We'll be doing some question now, some question later on. So the first thing we'll take up is this question number 2 and question number 3 from. So we'll start with this. So question number 2 says, on comparing the ratio A1 upon A2, B1, B2, C1 upon C2, find out whether the line representing the following pair of linear equation intersect at a point, are parallel or coincident. So out of these three, one has to be there. So there are three questions given. Okay, so I will show you one how to do it, and please whatever I'm going to write it, these are the steps which are required. Okay, if you want to make this question and you want to score full marks, then you have to write whatever I'm going to write. Don't make shortcut out of it, and don't make too much of lengthy out of it, right? So I'll come back to the page where we left it. So now I'm going to do this question for you people and show you how you have to write it. I'm going to erase it, all the thing which was written earlier. Yeah, I think it's clear now. So we are doing exercise 3.2, and the question is question number 2. So let's say I'm taking first part. So first part, what is the question? I'll tell you. The question is, the first equation given is 5x minus 4y plus 8 is equal to 0, and the second equation is 7x plus 6y minus 9 is equal to 0. So now let us check. So what we have to do first? First we have to see the ratio. So a1 upon a2, what we get? This is a1, 5, okay, and the second equation x is a2, so 5 upon 7. Already they are in lowest term, so I don't have to do anything, and if it's not, then I have to cancel and bring it to lowest term. Then I'll take b1 upon b2, it is minus 4. I have to take with the sign, and here it is plus 6. Yes, we can further reduce it because they are not in lowest term, so you should do it. Now you notice that these two are not equal. So if these are not equal, there is no need to go for C1 upon C2, because if A1 upon A2 is not equals to B1 upon B2, then what will happen? If A1 upon A2 is not equals to B1 upon B2, then what does it happen? Do you remember? The lines will be intersecting. Yes, I can show it here. Yeah, this table, right? You can see here this one, intersecting line, because A1 upon A2 is not equals to B1 upon B2. So now what we'll do, we'll write here that, or in the bracket you should write why it is not equal. The reason is because 5 upon 7 is not equals to this minus 2 upon 3. So right, thus, what was the question? Do you remember what was the question? The question was Um, representing the following pair of linear equation intersect. So the lines. So we'll write thus the lines will intersect. So that is the answer. Understood how this done? Any kind of doubt? No. Okay. So that's what we do. I'll take one more example for you. One more. That will be some extra. Okay. I'll do some extra question. Again, question number 2. So this is not from the book, but I will take question from my side. And these are all classwork, so you can also do the same question in the classwork. So the question is, just say I have 3x minus 7y is equal to 2, the first equation, and the second one is let's say 9x minus 9x plus 21y, okay, minus let's say plus, so minus, minus 8 is equal to 0. So I want to know what type of line it will form. So first what I'll do, I'll take a1 upon a2. What is a1 upon a2 here? It is 3 upon minus 9. This is a1, this is a2, and this will give you minus 1 upon 3. This negative can be transferred to the numerator. Okay. Next one is, I'll check what is b1 upon b2. It is minus 7 upon 21. So again it is minus 1 upon 3. So you can see these two are equal, minus 1 upon 3 minus. So that means I need to do the c1 upon c2. Okay. c1 upon c2 is, if you see, I have deliberately taken this 2, which is a constant, on the right side of equation and this on the left side. So either you take this one to this side, or you take this one to this side. They has to be same side. So if I keep it like this, it is 2, right? And if I transfer this to this side, become plus 8. So I'll take 2 and this one is plus 8. So this is also how much? 1 upon 4. So therefore the ratios are like this: a1 upon a2 is equals to b1 upon b2, but not equal to c1 upon c2. You can see c1 upon c2 is not equal. So if such condition happens, then what you will say? They are parallel. Okay. So here, because minus 1 upon 3 and minus 1 upon 3 equal, but 1 upon 4 is not equal. So thus the lines are parallel. No, it's no solution, but we don't have to tell solution, what type of solution it has. They were asking parallel, intersecting, or it is overlapping. So I hope you have understood how it is done or not. Any kind of doubt, if you have, you can ask me if you have any kind of doubt. Okay. So let us come back to our question again. So the first question we have, second question we have done. Now let's come to the first question now. Sorry, third question, not first question, third question. If you see the third question, they have written almost the same thing, that on comparing the ratios a1 upon a2 is equal to b1 b2 is equal to c1 upon c2 are not equal to, comma, find out whether the following pair of linear equation are consistent or inconsistent. So what does consistent and inconsistent means? This first I have to explain you. So for that, what I'll do, I'll go to little previous pages and book. If I can find something, I'll tell you. Consistent and inconsistent means what? There in the NCERT, I know it. Okay, anyway, so let's not waste our time. Okay, what is the meaning of consistent? Consistent means solution is possible. So this one and this one, there is a unique solution case and infinite many solution case. These two cases, the solution is there. Already there is one solution, there is an infinite solution, but solution is there. So they are called consistent. If you have this kind of situation, you will say it is consistent. Okay. And this is the only case where solution is not there, you will say inconsistent. So consistent means when you have some solution, maybe unique or infinite, and inconsistent means where there is no solution. And we can also split them into two more things, but I think this is not needed. But consistent, inconsistent, I think so you have understood. So let us go to the question again here. And the question is, we have to compare and tell that it is consistent or inconsistent. So same thing you have to do it. Almost all same thing. So which part we should do? I'll do the third part. Okay. The third part seems to be a little tricky. So I'll do the third part for you people. So I'm go back to my page where I'm writing. Yeah. So I'll take question 3, third part. So question 3, third part. And third part is, it is 3 upon 2x plus 5 upon 3y is equal to 7. 9x minus 10y is equal to 14 is the next one. So two equations are there. So first we have to find what is the ratio a1 upon a2. So this is 3 by 2 upon 9. This is a1 entirely. Okay. Now if I have to simplify 3 by 2 into 1 upon 9, because this 9 is divided, it is something like this: 3 by 2 divide by 9. So what we will do, 3 by 2 like this, right? So directly I have done it like this. So you can do it. This was the same thing, which I'll move this part now. So now it becomes 1 upon 6, you can see, because 3 and 9 cancel, 1 upon 6. So what is b1 upon b2 now? b1 upon b2. b1 upon b2 is, yes, you are asking something, Bache? I could not hear what you said. If anybody was saying something, please repeat it, because what you said I could not hear it. Inconsistent. Very good. So 1 upon minus 10. So it becomes minus 1 upon 6, because 5 and this will cancel 2. So minus 6. So you can see very clearly this is 1 by 6 and this is minus 1 by 6. They are not equal. So you have to be very careful about the sign. Sometimes the student do a mistake and they say they are equal. They are not equal, because 1 upon 6 is not equals to 1 upon 6 is not equals to minus 1 upon 6. So thus, here we can write therefore. Thus, what was the question they were asking? Let's see. The question was the pair of equations. We can write therefore the equations are inconsistent, and if the situation comes something, you write consistent, inconsistent, consistent, like that. So I hope you have understood how it is done. Okay, so in the today's chapter we have learned few things. The first thing what we have learned is that linear equation two variables, okay, it has infinite many solution if it is a single kind of linear equation two variable. But if a pair of linear equation given, then three cases may be there. Okay, the both the equations may form a unique solution, that is a common solution for them, or they don't have any solution with them common solution, or they have all the solution of one equal to the solution of other infinite many solution. And also we have learned about the geometric concept or the graphical concept. The lines will intersect, they will be coincident, they will be parallel. And then we did some question based on that. If some question they ask, what type of question they can ask you. So these questions we have done today. Okay, now doubts session. Anyone want to ask anything? Yeah. Consistent. Yes, it is consistent. Sorry, but I have written inconsistent. Inconsistent means no solution. It is having a solution. It's a consistent. You are right, Uche. It is consistent. I didn't realize that one is consistent. It is consistent because I told you if you have these two kind of solution. I also yeah. You can see I have very clearly written here. If you have these condition where a1 upon a2 is not equal to b1 b2, or if they have all the three equal, then it is a consistent case. So it is a inconsistent will be only in this case where you have no solution. That is inconsistent. So yes, right. So you are absolutely very correct that it is a consistent, not inconsistent. Any other thing, Buche? Any other thing you want to say? Okay. So what we will do is that your homework will be to complete the remaining question of this exercise, right? So I'll write it here, the homework. You'll get this homework on the page in the Google Classroom. So I'm writing it homework here. Homework is exercise 3.2, question number 2 and question number 3. Complete the remaining part, right? So this is the homework which you have to do. So remaining thing will now take up tomorrow. So for today, I think so that session is over.